Niels Axel Mørner is on his way to the tiny island of Los Fushi with Musa Manik of EcoCare in the Maldives. They're carrying a piece of the skull of a skeleton that appeared from the coral reef there a few years ago. On the evidence of where the skeleton was found, and from carbon-14 dating, the sea level at the time the woman lived may now be reliably ascertained.
Now we are coming out on this beach rock, a beach cemented into a hard rock. And outside there we see rock sticking out, and that's the place where you found
the woman.
The woman.
What actually happened to us was that somewhere along the line, a few years back, we heard that there was a skeleton embedded in the shelf. So we came and asked the people there. Then a lot of elderly people had said that it had been there for a long time.
Yeah.
So we thought we would perhaps go and see that. And then we wrote the article, and you got the article.
Precisely. We go around and see. That's a good idea.
Go that way, and then
that's a good idea. The reef woman was embedded in a beach sand at about same sea level as today's sea level. And that was 1,200 years ago. That's the ribs, yeah. And here is the skull. So this one should have come here, I think.
Right.
And because she has a very delicate cranium, we can be sure that it's a woman. So you were completely correct. Because of its position in the reef, we can see that she lies embedded in the shore sand. And that shore sand is then covered by a cemented coral rubble, which tells us other things, that subsequently to that level, 1,200 years ago, sea level rose, brought this rubble together and cemented it, then fell back in a couple of steps. And those steps are quite remarkable. In the last 200 years, sea level has been about 30 centimeters higher than today. At about 1970, something remarkable happened. Sea level fell down to its present position. That fall in sea level, which no one had expected to see, we can see all over the Maldives. It's very well recorded and established. And that, of course, gives us a completely different story than it's generally given. Here we are at the top of the present-day wave action. They deposit these coral fragments, and they are white because they are rounded by the waves of today. The other level, the gray level, is the top of the waves at the previous time. So that means a difference in height means evidence, real evidence that sea level has gone down. It has not gone up.
So the sea level around the Maldives is not rising. On the contrary, there has been a remarkable fall of 20 to 30 centimeters in the last 30 years. The conclusion of Nicholas Mørner's observations may be that archipelagos like the Maldives will not be inundated after all.
I think the reason for this fall in sea level about 1970-75 is a strongly increased evaporation. The Indian Ocean is very warm, and the evaporation is exceptionally strong. And that strong evaporation has made the sea level in this region to be exceptionally low. So it's 30-40 centimeters lower than gravity tells it that it should be. And that's quite remarkable. I mean, it's going up so much water vapor that it has not time to fill. Those things were, for me, exceptionally interesting variables to study.
Evaporation from the oceans may actually ward off any future rises in sea level. Evaporation from the tropical oceans to the atmosphere moves the enormous volumes of water to other locations like the poles, where it falls as snow.
A rise in evaporation is a cause of that it becomes warmer somewhere. That's interesting. And it means if it gets more evaporation here over the Indian Ocean, somewhere else it can get more precipitation. But you cannot have increased precipitation somewhere if you don't have increased evaporation somewhere else. And that is the balance of the globe.
If Greenland and Antarctica melted tomorrow, simple arithmetic tells us that the sea levels globally then would increase by about 100 meters, which is a lot, but that's simply a matter of the amount of ice that's been built up. But it will not do that over 1 year. It will take about 2,000 to 3,000 years for it to do so, so it's a slow process. But then if we go to the question of the biggest piece of ice in the world, East Antarctica, which equivalates something like 80 meters of sea level rise, will this melt in the future? The answer is definitely no. The average temperature in East Antarctica is so much below zero that even if we got a greenhouse effect, say, an enhanced greenhouse effect that would equivalent 10 degrees change on average, it would not melt the East Antarctic ice sheet because it's so cold. What it would do instead would make the ice grow. And it would make the ice grow simply because when the Earth gets that much warmer, there'll be so much more humidity in the atmosphere, and that will increase the snowfall in Antarctica significantly. So therefore, it sounds like a contradiction, but if we get a warmer climate, East Antarctica will grow.
The warmth of the tropical ocean generates enormous amounts of water vapor, which is distributed to the rest of the world and falls as rain or snow. So water vapor, clouds, and precipitation play a decisive role in the climate throughout the atmosphere. The United Nations Climate Panel bases its scenarios on what will happen if we double the amount of carbon dioxide in the atmosphere. This would not only result in a climatic disaster. The calculations say that more carbon dioxide would also increase the amount of water in the atmosphere. It is this cocktail, more carbon dioxide and water, that according to the theory must lead to a greenhouse effect many times as great as carbon dioxide on its own. The trouble is, temperature increases in the atmosphere just don't seem to have happened to the degree that the models predict.